All right, so Sky, can you tell me how you're starting this number 5? Might not be done yet, but how are you starting it? Okay. All right, so I'm gonna have Sky walk me through part A, and then Dylan, get ready. I'm gonna have you walk me through part B, okay? Dylan G is who I'm talking to. So Sky, you know how to get it started? Okay, so the stuff that I have in blue here, let's make these guys work together. So they told me that tangent of theta is a 1/3. So in this equation, I'm going to make my tangent theta, I'm going to make that a 1/3. All right, you okay with that? Okay, I'm going to do a 1 plus, instead of tangent squared, I'm going to do my 1/3 squared. And that'll equal a secant squared. Okay, all right. All right, so then walk me through how to solve this then. Sky, you there? Yeah, okay, cool. So walk me through how to solve this. Let's just solve for secant first. We'll deal with this in a sec. Let's solve for the secant first. So yeah, Dylan, let's have you just pick it up from there. So Sky, I'll come back to you in a sec. Get ready for it, okay? All right, so Dylan, how would you solve for that secant? Okay, so I'm assuming you got your 10/9. You combined this, it's like a 9/9 and a 1/9. You combine it for a 10/9. Nice. Okay, and then you got rid of this squared exponent. You did a square root on both sides, so you've got a square root of 10/9. All right, so your secant here, so you kind of took care of this one already. Your secant is the square root of 10/9. Now, can I simplify that at all? Like, do you know the square root of 10? Do you know the square root of 9? Let's simplify this fraction here. So Dylan, what's the, do you know the square root of either of those? Oh, square root of 10 and then over 3. So you know the square root of 9 is a 3. We don't know the square root of 10 though, so we have to leave that the way it is. Which I think we talked about before, how you can have a square root in the numerator. That's considered simplified, but you can't have a square root in the denominator. So this actually is considered simplified. So my secant of theta was root 10 over 3. I think the cotangent actually was a bit easier. I actually didn't even need the formula. And so let's look at our identities up here. My cotangent is 1 over tangent. It's like the reciprocal of my tangent. And because they gave me tangent, I'm just going to do the reciprocal of that for my cotangent. All right, so Sky, I'm going to come back to you. What is the reciprocal of this tangent? Nice. So you didn't even put 3 over 1, just straight up 3. That's what I would do as well. Okay. This, though, the stuff I had in blue, that was your identity to go help you find secant. All right, do I have any questions here? Froze, you guys don't have any questions? Okay. So then next up, we're going to use the trig identities to transform the left side of the equation into the right side equation. And we're talking about between 0 and pi halves as far as radians go, which we talked about this a second ago, but between 0 and pi halves is pretty much saying you're in the first quadrant. It's kind of their way of saying quadrant 1. Okay, that's what these guys are saying. All right, so use the trig identities to transform the left side of the equation to the right side. I'm trying to get all of this stuff equal a 1. I'm trying to prove that it actually equals 1. So let's see, out of my identities, I had, let's see, it was a secant. Wait, what was I looking at? It was sine and cosecant. Okay. Let's see how I can make those multiply to be 1. Sine and cosecant. Let's look at these guys. Cosecant is like the reciprocal of my sine. It's like 1 over sine. So I'm going to replace this cosecant with a 1 over sine of theta. I still have the plain sine theta here, which I think this helps us out because the sines divide out and I just have 1 equals 1, which is true. So we have pretty much proven that that is a true identity there. So we transform the left side into the right side. Part B here, this definitely takes a bit more effort. I'm going to have to distribute. All right, so I get a cosecant times cosecant, just cosecant squared. All right, I get a negative cosecant times cotangent. Does this look like any formula of any kind to you guys? What? I was just wondering if this looked like a formula for you at all. Difference of squares, does that sound familiar at all? This is going to end up being a difference of squares. So I have a negative, I put cosecant times cotangent and then cotangent times cosecant, but they are the two same things multiplied together. One of them is positive and one of them is negative. So for that reason, those add up to 0. Bam, gone. So I'm left with cosecant squared minus cotangent squared equals 1. All right, this equation, this is making me think it's one of those Pythagorean identities. Let's look at that. All right, so cosecant, cotangent. Okay, this one's got the cosecant. This one's got the cotangent. It says 1 plus cotangent squared, though. Let's see if I can match that. If I add that cotangent squared on both sides. All right, so it now says cosecant squared equals a 1 plus cotangent squared theta, which is true, but that was one of our identities, so I can be like, check. We just proved that it was true. Same thing up here when it was like 1 equals 1. Yeah, that's like for sure true. Okay, questions on these like identities. You're gonna have to basically use the identities to show that both sides of the equation are equal. You'll have to do that on homework, quizzes, that kind of thing. Any questions? Online, we good? Ooh, no response. Should I be worried? Oh, thank you, 80. All right, thanks, Justin Kislev. All right. We're doing all right? Trying to show that those are both actually equal to each other. Thanks, Marcus. Okay, then let's look at these guys. These are their word problems. This has to do with an angle of elevation and an angle of depression. So notice that it's highlighted. You've got to deal with a horizontal line. And then it's either elevating going up from the horizontal line, or it is an angle of depression going down from the horizontal line. But it's got this horizontal line. They're going to use a lot of word problems for this kind of thing. So like this one right here, a surveyor stands 100 feet from the base of the Washington Monument. The surveyor measures the angle of elevation to the top of the monument to be 78.3 degrees. So you can see this right here. Angle of elevation goes from this horizontal line, like the ground basically, up to the top of the monument. So here's your angle of elevation. All right, so how tall is the Washington Monument? You got to find like this Y right here. You got to find how tall it is. So if you just look at the triangle, really, see a right triangle with 78.3 degrees in that corner. I see 115 feet right here. And then there's the Y that I got to find. So I'm just kind of considering the triangle, which based off of that, I've got, let's see, opposites. The Y is opposite from my 70, I'm using the 78.3 degrees. Y is opposite of that. The 115 is adjacent to that. And I don't really know anything about this distance. This is the hypotenuse, but I don't really have much information about the hypotenuse. So I'm trying to look for which trig function would use the opposite and the adjacent. So I don't know if you guys watched the video last time, but here's my trig functions. I want which one uses the opposite and adjacent. So I'm going to go with one of these guys, either tangent or cotangent. And I think I wanted the opposite. I think I'm going to put my opposite in the numerator just because that makes it easier to solve for. So I'm going to go tangent. Tangent is opposite over adjacent. Okay, so my tangent of theta, my tangent of this angle, 78.3 degrees, is the opposite Y over the adjacent 115. Okay, so let's compare that to the other one. If I did cotangent of 78.3 degrees, that would give me, instead of opposite over adjacent, it would give me adjacent over opposite. So these are both true. I could use them both. I feel like the top one here, the tangent one, it just has the Y in the numerator. It means I only have to take one step to solve it. If you chose this one, you'd get the same answer. You'd have to do like 2 whole steps instead of 1 step, but I mean, you'd get the same answer. So I'm going to stick with the tangent one here. I'm going to multiply by the 115 on both sides to get my Y by itself. And I will put this in my calculator here. Come on. so 115 times tangent of 78.3 degrees. What do I have to check on my calculator? Do you guys remember?
It's in degrees.
Ooh, if it's in degrees. So I'm gonna go, for me, it's a mode button. I don't know which button you guys have to check on your calculator. If I go to the mode button, oh, my mode is currently in radians. So if I did this in radians, okay, that's what I would get, a negative. It's like I got a negative side. I don't know about that. I need to put my mode into degrees. I was talking 78.3 degrees. Okay. All right, there we go. 555.3139, yada, yada. That was this height in, what were we talking? Feet. We're talking feet. So my Y was 555, if I round to the nearest whole number, 555 feet. Okay, if I got a negative, that would kind of be an indicator. Something's a little off. I shouldn't have a negative height, right? So that was my degrees versus radians in my calculator. Check your mode when you do this. If you did the cotangent, I should be able to get the same thing, really. It just would take me an extra step. I would have to like multiply the Y over to the other side first, and then divide that cotangent of 78.3. But let's check this out. Let's see if I get the same thing. 115 divided by cotangent. Do you guys have a cotangent button here? Oh, I have a sine button. I got a cosine button. I've got a tangent button. Does anybody actually have a cotangent button?
No.
I don't think you do. So what I would have to do is I would have to treat cotangent as 1 over tangent. Okay, so if I treated my cotangent as the reciprocal of tangent, then yes, I got the same answer. But I don't have a cotangent button. All right. Yeah, nice, Justin. 1 over tangent. Now, I noticed I put it in parentheses and everything. Like the entire cotangent is the entire 1 over tangent. All that had to be in the denominator. Okay, but I did get the same answer either way. Like I said, I chose what's in blue here. I just thought that was the easiest way to solve it. Not that I wouldn't get the same answer. I just tried to pick the easier way. Okay, any questions on this one? $555 feet. All right, then let's have you guys take a second. You're not finding a side now, you are finding an angle. Let's have you guys take a second, pick which trig function you're going to use. Sine, cosine, tangent, secant, cosecant, cotangent. Which of the 6 trig functions are you going to use? All right, Shara, which one did you go with?
What?
Oh, I'm asking Shire which of the 6 trig functions she's going with. Okay, all right, we'll come back to you in a sec then, okay? Did you pick one?
I picked cosine.
You picked cosine? Okay, so what made you go with cosine?
Because we had the adjacent and the hypotenuse.
Oh, the adjacent. Oh, maybe I'll put some another color here. Goodness gracious. Okay. The adjacent was the 3 miles?
Yeah.
You said hypotenuse as well?
Yeah.
Hypotenuse was the 6 miles? Okay, so you went with cosine of some angle is the adjacent over the hypotenuse, so the 3 over 6. Nice, okay. Pretty much you went with whatever doesn't have the opposite side, right? Were there any other trig functions that don't have the opposite side?
Yeah.
There is? What's the other one I could use then?
There's, like, secant.
Yeah, so nice. Dylan, you got the same thing? Yeah, secant. So you could do, if you did secant of theta, secant of that angle is, instead of adjacent over hypotenuse, it is hypotenuse over adjacent. So it'd be like 6/3. Again, personally, I think I would go with this one just because I have a cosine button in my calculator. It'll just be a lot easier. So there's actually a couple different ways you can do this. So this is down to a 1/2, right? You can actually put it in your calculator, or you can pretty much look at the unit circle. Is there any spot on the unit circle where your cosine, like your x value on your unit circle, is a 1/2? So I'm looking at my unit circle right here. I'm looking for the x value to be a 1/2. And I've got to be over here because we were talking about a triangle. I can't have a triangle that's somewhere else. So I'm going to go, I think with my x value of 1/2, I'm going to go with this one. Which, do you guys remember what angle this was? Yeah, 60 degrees. Nice. If you're going with degrees, you got 60 degrees. If you're going with radians, it would be pi thirds radians. Let's see, do they specify if they want degrees or radians? No, it just said find the angle. Okay.
No.
Off my unit circle, I could tell, yeah, we're talking 60 degrees or pi thirds. I'm gonna go with radians. I'm gonna go with pi thirds there. All right, if you had to put it in your calculator, I think my calculator is currently in degree mode right now. So let's see if it gives me 60 degrees. I could do, let's see, the inverse cosine, the little -1, it's an inverse function. It's gonna give you, when you do an inverse, you kind of swap the input and output. Usually you put in an angle and you get out some cosine, like some x value. But we did an inverse, we swapped the input and output. We're gonna basically put in the x value and get out the angle. All right, 60, so like 60 degrees, which pi thirds, 60 degrees, same thing. All right, if you're not familiar with the inverses, don't stress about that. We had this on the unit circle. We could find this off of the unit circle. All right, so I think that's like the last problem for today. Do you guys have any questions on this stuff?